Hey everybody, this is Professor Monty, and today we are jumping into chapter 3. Specifically, we're doing 3.1 and 3.2. So let's start with 3.1. It's called Measures of Center. So the idea is, how do we measure what we would refer to as the center of a data set? And there's 3 different ways we typically talk about the center. The first one is what we call the mean. And what the mean is, that's just the average. So we find the mean the way we normally do is we just add up all data and then we divide by the number of data pieces. Numerically, what we would do is to say we add up all the data is we do this symbol that's a sigma, which stands for the sum, meaning we add up all the x's, and then we divide by n, where n is what we call the sample size. So it's the typical way that we find the average of something. We add them all up and divide by however many we have. Now, when we do it this way, we call the mean, if it's the sample mean, we'll talk about later in another lecture about what we call the population mean, but if it's just a sample, we call it x bar. And again, we get it by just adding up all the x's divided by the n, or the sample size. And that's my formula. So that's my sample mean. Again, it's called x bar is the way we pronounce that. Let's erase that one. See the formula a little bit better, but that's just my average. And the average works real well. A lot of times you'll be in class, the instructor will talk about the average score on the test. We may talk about your average GPA, all those types of things. Average number of kids that, or the average number of people that live in a household. All of those would be the mean or the average, and they work really well. The second way we often look at it is what's called the median. And what the median is, it's the middle data value in ordered data. But it's the middle value. Now, if we have an odd number of data, we would have a middle. So let me just make this up, and I'm going to put these already in order. So say we have 1, 2, 5, 7, 9. Well, the middle piece is 5. That's going to be my median. And notice what's nice about the median. It didn't matter if this 9 was a 97. The median doesn't change. If I was adding up all those data points and finding the average or the mean, that would really make your mean a lot larger. But with the median, it doesn't get affected by really high or really low values. And so sometimes we use the median. They use it a lot of time in house values in an area, because if you have a few houses that are really expensive, it's going to make the average house value a certain number, but it may make it appear to people that it's a more expensive area than it really is. So what they'll do is they'll say, you know what, here's the middle house value. So they'll find the median home value. Now, if we had an even number of data pieces, say we had 2, 6, 8, 10, we'll just leave it there. Well, this time we don't have an odd number. There's no specific middle piece. So we look at the 2 middle pieces and find their average. So the median is just going to be the average of these 2 middle pieces. So the median this time is just going to be 7. Okay, so that's the idea. If there is a true middle, it's the one right in the middle. If you have an odd number of data pieces, if you have an even number, it's the average of the 2, quote, middle pieces. Okay, so that's the median. Again, you'll use that when you have some extremely high or extremely low values. And then the last one that we see is called the mode. And the mode is just the most frequently occurring number. And so if no number happens more than once, you would just say there's no mode. If you have two numbers that tie for the maximum number of times, the largest number of times, then you would say, oh, I have two modes, and you would say what they are. But say you've got, say the numbers 1 through 10, and you've got 3 5s and 3 6s, and you have 2 10s. Well, the 10's not the most frequent, even though it's more than once. You would just take the two that happened the most. And if they tied for the most, then you would say these are my two modes. So you could have several modes, or you could have no mode, or you could have one mode. So that's the mode. It's the most frequent number that we have. One thing interesting about the mode is that if I have qualitative data, remember qualitative, it's non-numeric, I can have a mode because something happens the most frequent, or there's more than one mode, but I can't find the mean or the median because, one, you can't find the mean because you can't add them all up and get a number that you can divide by anything. And you can't have the median because you can't list them smallest to largest because they're not numbers. Okay, so mode's the only one of these three we can actually use for qualitative data. Okay, so that's the main idea there. What I want to do is I want to look, and I'm going to go into my stat lab or my lab statistics, depending on how you want to say it, and show you a problem from the homework to show you how this works and to show you how easily StatCrunch can do these problems. So bear with me. I'm going to go here. I don't want that up. So let me do this. I'm going to go here. I already pulled up StatCrunch. So right now I'm just in where I've got my classes. If you're going in through Canvas or Blackboard, you may or may not see this, but let's pick a class. We'll pick a Math 10 statistics class, and I'll go in there. And all of the homework and all the exams are right here under homework and exams. Your class, it may look a little bit different than that, but that's what we have here. I'm going to click in there and see all of the homework is by chapter. Notice here, all three of these chapters have the same due date. They're all on the 10th. So bear that in mind. Don't finish chapter 1 homework and say, oh, I'm done until, you're not done until you do 1, 2, and 3. But this is in chapter 3. So let's take a look in there. We'll click in there. And what I'm going to do is I'm going to go into problem 5. Now, problem 5, what it does is it's going to give me some data. It says, in a study of the effects of radiation on amphibian embryos, the time it took a sample of 7 different species of frogs and toads' eggs to hatch was recorded. The following table shows the time to hatch in days. Complete parts A through C below. All right, so let's do it. Find the mean. Well, we know we can just add these up and divide by however many there are. That's going to be the mean. But I'm going to let StatCrunch do all the work for me. You're welcome to do it by hand if you'd like to. Notice underneath the answer, it says type an integer or decimal rounded to 1 decimal place as needed. That's the standard rounding in statistics. You look at your data, and if you have to round something off, you never round until you get to the final answer. But at the final answer, if you have to round it off, the rounding rule is you round to 1 decimal more than your data. So since my data is 0 decimals, I would round the mean to 1 decimal if I need to. Okay, again, you don't round until the end though. This one won't be too tough to do. And let me show you something about this. So right here, there's this little symbol. If I click there, I can open the data. I'm going to open it in StatCrunch. I could go to the clipboard at Excel. I always go into StatCrunch. And this is the computer program that's going to do work for us all semester long. It's fantastic. So I go into Stat, and I go into Summary Statistics. My data is all in a column. Columns go up and down. Rows go across. So they're all in a column. So I'm going to pick columns, and it's going to say what column. So I have to pick the column. If you forget to pick the column and you try to compute it, it's going to say, wait, there's nothing to compute. You have to pick a column. So I just click on variable 1 here, and then it goes over there. Now it's selected. All these things over here on the right are what they've set up to calculate for us. So it's going to do n, which is the number of data pieces. It's going to find the mean, is which what I want, and a bunch of other stuff in here. We can look and see what it's going to find for us. And if we want more than that, there's other stuff over here. And we may look at some of that stuff. all I care about is the mean. All I do is compute. And it's going to say, hey, the mean right here. Now remember, round to 1 decimal place. So I'm looking at the 7.8, but I need to look at the next decimal to realize if I round up or I leave it at 7.8. And remember that rounding rule, if that's a 5 or above, you round up the previous digit. So that 7.8 becomes 7.9. And so now when I go back to my problem, and I say, oh, the mean is 7.9. So let me type that in here real quickly. 7.9. Oops, that did not go in there. Let's try that again. Click in the box. There it is. Now it's in there. 7.9. And I'll check my answer. And lo and behold, I got it right. They give you positive affirmation if you get it right, which is always nice. Find the median. Oh, I actually didn't check for that, but it did calculate it for me. So now let's go back, and it's right here. What was my median? Oh, it was 7. All right, so let's type in a 7. Hopefully you saw that when I clicked over there. And what's the mode? Does it have a mode? Oh, well, let's go check. So I'll pull this all the way up just in case you didn't see it last time. So the mode, does it say anything about mode? It didn't check for the mode. Here's what we do. Let's have it check for the mode. Let's do this again. Let's go stat, summary statistics, columns, variable 1, over here down at the bottom, it has the mode. So this time I'll pick that. That's all it's going to pick. But if we wanted, say, the mean, median, I think we have to hold down shift or control. Let's see. If I hold down control, we get the mean. Now I'll hold down control. The median, so control, median, however your computer works, and mode. So I've got the mean, the median, the mode. I'll give you a hint. On one of the problems, they have us calculate, like the mean, find the sum of x and find n. If you want to do that, those are over here too. So the sum of x, oh, there's n, but let's find the sum of x. That's the sum. And then n is obviously n, that's my sample size. So now if I go compute, it's going to give me the mean, the median, the mode. Oh, there's multiple modes. So what I have to do is I have to determine what they are. Remember, the mode is the most frequent. So let's see, there's 2 7s. There's also 2 4s, and there's also 2 14s. And that's the most anything occurs. So I'm going to go for 7. I don't know if I have to put them in order, but I will just to be safe. So 4, 7, and 14. So let's go back over here. The modes are, what do we say, 4, 7, and 14? It says separate by a comma, 4, 7, 14. Let's check that. Got it again. And, oh, it says questions complete. Go on to the next problem. Notice find n, find the sum of x, determine the sample mean. So we could do all that with StatCrunch as well. I'm not going to do that problem because we know how to do it. All right, so we've got that. That was pretty nice. Let's go back into our material and we'll talk about this. So there's one more thing I wanted to bring up about what the distribution looks based on the mean and the median. So let me pull up a picture for us real quickly. And the picture I have in here, and I'm going to copy that. And I'm going to go paste it in where I need it, which is right here. Okay, now here's 3 different distributions and the mean and the median. Remember what we talked about. If you've got something that's pulling the data off to one side or the other, so really high or really low numbers. This first graph here, it's showing that we've got some values that are really high. They don't really fit with the rest of them. They're especially large numbers. Well, that means this graph is right skewed. Well, if it's a right skewed graph, it's going to pull the mean out there because these really big numbers make the mean look higher or make it higher, but it didn't change the median. We know the mode is always the most frequent. So if I just put a line in right here, that's going to be the mode. And the line right here that we already have, that's the peak, so that's the mode. And here the mode's going to be over here. So the mode's always the most frequent. But notice if it's symmetric, there's equal stuff to the left and the right. Oh, I didn't want to do that. I want to get rid of this. There's equal stuff to the left and right. We call it symmetric. The mean and the median will be the same. And the mode is also equal to those as well. If it's left skewed, meaning you get some really small numbers, that pulled the mean away from the median. Notice it also pulled the median away from the mode. But notice the order. The mean always gets pulled further to whichever side has the longer tail. And the median gets pulled over a little bit from the mode, but the mode is always where it's the most frequent. Okay, so that's the idea. Those are the three things we look for the measures of center. The mean, which is the average, the median, which is the middle, but you have to order the data smallest to largest first, and the mode, which is the most frequent. You can have one or more than one of those. All right, let's go into 3.2, measures of variation. Okay, so measures of variation, there's a really simple one. The first measure of variation is the range. So we're talking now about how much these data values vary from each other. And the range is just the max minus the min. We just do a little subtraction and we get a number. What's nice about the range is it's really easy to compute. What's not so nice about the range is it only takes into consideration two values. So if I've got scores on my exam and somebody got a 0 and somebody got 100, I would say the range is 100. Well, it didn't really teach us a lot. Are scores grouped around the 70s? Are they grouped around the 80s? You know, where's the mean? Where's the median? We'd want to know about that. Are the numbers varied? Maybe everybody in the whole class got 100, except one person got a 0. The range is still 100. But something else we can look at that takes into account all the data is called the standard deviation. Let me explain what the standard deviation is. And then what I'll do is I'll show you how to compute it. But here's the good part. We don't have to compute it in our class by hand because StatCrunch is going to do it for us. But what is the standard deviation? What it stands for, it's the average distance each data value is from the mean. And so to calculate it, what we do is we take each x value and we subtract it from x bar to find out how far that data value x is from the mean x bar. And then we add all those up. But we have a problem. Remember, we use that little sigma symbol to say we sum or we add those up. But here's the problem. By the fact that that's the mean, you've got equal amount of value below the mean as you do above the mean. So some of these are going to come out negative, some are going to come out positive. If we do this correctly without rounding, we always get exactly 0 for that sum. So that's kind of nice, but kind of not. So here's what we do. We say, well, you know what? Before I add those up, I'm going to square them because now we don't have any negatives. They won't cancel each other out. Now that's going to represent the squared deviations the values are from the mean. And to find out what that is on average, what we would do is what we always do with an average is we divide by n, the sample size. Well, what they get is they get something called, they call this S squared. It's called the sample variance. I usually don't do anything with the sample variance. I don't know why I'm spelling variable. It's the sample variance. Now, we're trying to use this to estimate what the population variation is. They found out by doing lots and lots of these studies that dividing by n actually underestimates the variance. So what they do is they make it n minus 1. Sounds a little bit weird, but that comes out closer. It's a better estimate to what the actual population variance is. The problem with this S squared, this sample variance, is think about the units. Suppose X is in years. So let's talk about maybe the average age in the class. And let's pretend the average age in the class is 20. If somebody's 18, the X would be 18. 18 minus 20 is negative 2. So they vary from the average age by 2 years less than the average. That's why it's negative. Well, if we square that negative 2 years, think about this. If I have got negative 2 years and I square it, that negative 2 becomes a 4, which is okay because it's not going to cancel out with anything, but that years becomes years squared. And what in the world is a square year? Nobody knows. So what we do instead of the sample variance, S squared, we look at what they call the sample standard deviation. To get rid of that square, we just take the square root of this sample variance. So we take the square root. Now that is the sample standard deviation. And remember what it represents is how far on average each data value is from the mean. Okay, so that's our sample standard deviation. It's kind of hard to calculate. There's that formula. There's also a computation formula that makes it a little bit easier if you have a lot of numbers. Let me show you one of these. Again, we're just going to use the computer. So if you're having trouble following along, don't worry about it too much. But I want to show you how this works in case you need to do it. And again, you won't need to do it in my class as long as you're using the technology that we have. So let's say our data looks like this. Let's use 1, 3, 4, and 8. And I want to find the sample standard deviation. Well, the first thing I need to do is find the mean. And the mean, remember, that's X bar. You add up all the X's and divide by N. We'll actually just do this by hand. So 1 plus 3 plus 4 plus 8 divided by there's 4 data values. So here, N equals 4. And so let's see. I get 12, 13, 16. So my X bar, 16 divided by 4 is just 4. There's X bar. I found the mean. But now what I have to do, I have to use that formula. Here's my formula. So it's the sum of each of these X minus X bars squared divided by N minus 1. All right, so let's do this for these values. And what I usually have to do, I set up a table. I say, okay, what are my X values? What are my X minus X bar values? What are those things squared? And then I can add them all up. So there's my table. And I'll put in my X values, 1, 3, 4, and 8. Now I'm taking the one, remember we just said X bar was 4. So this first value here is just going to be 1 minus 4. So it's negative 3. And this one's going to be 3 minus 4. So it's negative 1. This one, 4 minus 4 is 0. 8 minus 4 is 4. And notice if I add those up, this is going to be the sum of X minus X bar. Those add up, the negative 3, negative 1 is negative 4, cancels out with the 4. I get exactly 0, which I said was the problem why we had to square it in the first place. So now I square all the X minus X bars. This is a 9. So that was the negative 3 squared. And the next one's the negative 1 squared, which is 1, etc. So I go down 0 squared is just 0, 4 squared, 16. So the 9 and the 1 is 10 plus 16 is 26. That's my sum of X minus X bar squared. So now I can just plug that in. So my S, that numerator is 26. Denominator, remember N was 4, so it's 4 minus 1. And it's the square root. We'll make life easy, make it the square root of 26 over 3, and then I can calculate that. Remember, we round to 1 decimal place. I don't want to put the 26 divided by 3 and then take the square root by rounding it off. I don't want to do 26 divided by 3 and round it and then take the square root. So I'm just in my calculator, I'm putting in the square root of 26 divided by 3. And what I get, 2.9439 stuff. So 2.9439, there's more stuff out here, but I want to go to 1 decimal place. Because remember, with calculations, I go to 1 decimal more than the original data was. So I'm going to go there. So I look at the next number, which is a 4, which is less than 5, so I don't round up. So my standard deviation, my sample standard deviation to 1 decimal place, 2.9. Had that been a 2.95 or a 2.97, I'd round up to 3.0. But since it's less than 5, I do not round up. I just leave it at 2.9. So that's the idea. Now, as I said, though, it's much easier to do on the calculator or computer. We're going to use the computer. Let's go back in here and do a problem. This is problem 10. So what I'm going to do, I'm going to take this and say, let's do problem 10 instead. All right, use the defining formula. Remember, the defining formula is what we just did. That would have been my S equals the square root of x, the sum of x minus x bar squared divided by n minus 1. You don't need to use the formula there. You can if you'd like to. Feel free, in fact, to use that if you want to, but I'm not going to. I'm going to do what we did before. I'm going to click here to open the data. There's my data. I'm going to click here to copy and open it in StatCrunch. So I go into StatCrunch, again, summary stats, columns. Variable 1, click on that, make sure it's over here. This time, they ask for the standard deviation. Well, there's my standard deviation right there. It's in here. I'm just going to say compute. So it gave me a bunch of things. Notice over here, it did give me the range. So the high minus the low. Let's see. The high was 16 minus 8. 16 minus 8 is 8. Oh, yeah, that's the range. But it gave me the standard deviation. Oh, 2.7. Now, remember, this isn't the same data we just used. So it's just completely different numbers. But let's go. Oh, it's 2.7. I don't round up because the next number is a 3. Make sure you round correctly. It'll mark you wrong if you don't round correctly. So, or if it says round to 1 decimal and you round at 2 decimals, it's going to mark you wrong. Make sure you follow the instructions and round to what it tells you to. So let's see. So 2.7. So let's go back in here. Where am I at? Here's my homework. Let's see. We can close that. S was 2.7. So I will go ahead and enter that in. So let's do this. Pulled me out again. Click back in there. 2.7. Ooh, round to 3 decimal places. And I just told you to do what they say, and I'm not following my own instructions. So we will. 2.738. Next number is a 6, so I have to round that 8 to a 9. So 2.739. Check that answer. Yay. Now it says replace the 16 by a 166. Oh, good heavens. Here's what we need to do. Replace the 16 by 166. All right, let's try it out. So I go back here. Let's close this down. They want this 16 to be a 166. All right, let's try it again. Stat, summary stats, columns. Variable 1, let's go ahead and just compute it. This time the standard deviation, 51.550. Next number is 5 or bigger, so I round that up to a 1. So 51.551. 51.551. 0.551. Let's check that. Hey, we got that right as well. Compare your answers to A and B. The lack of what property of the standard deviation accounts for its extreme sensitivity to the change of 16 to 166. Well, the standard deviation in part B is, let's see what our choice is. Well, it's obviously greater than the standard deviation in part A. The standard deviation isn't resistant to outliers. And so the rest of those really don't make any sense. An outlier is just a number that's far from the rest of the data, doesn't fit in with the rest of the data. Well, the 166 didn't fit in with the rest of those, which accounts for its extreme sensitivity to the change from 16 to 166. We will check that. We got the right answer again. Notice this time it doesn't say next or whatever it said. It says next question. So we're done with problem 10. We click on that, it'll take us to problem 11. Another type of problem, same way, find the range. Remember, it showed us the range in there. We could just do the high minus the low. But so not too bad. That actually gives us kind of a nice idea of how to do that. And in fact, it allows us to go ahead and do these computations real quickly. What I'm showing on the screen right now is how to do it by hand, but we don't need to do it by hand. You may have a teacher that says do it by hand. I don't think doing it by hand helped us understand what it is. I usually will say, hey, what does it mean? And then you say, oh, that's the average number away from the average each data point was. Yeah, that's what that represents. So I want you to understand what it means, but just doing a bunch of computation isn't necessarily what I want you to do. So anyway, practice these. Ask me if you have any questions, and we will talk more about this next time.